Okay, we're looking at angles today. Hopefully you've got an idea from everyday life what we mean when we talk about angles. We'll look at the two main contexts and then we'll look at categorizing different angles. Okay, so there's two main ways you're going to see angles crop up. The first one is where lines meet. Okay, there can be many different contexts to this. You could just have, I don't know, let's draw a line here, shall we? Okay, and then I'm going to draw another line, just crossing it anywhere. And wherever I cross this line is going to create some angles. Okay, so we're going to have an angle here, an angle here, an angle here, and an angle here. Okay, so any two lines that meet will cause angles. Angles will be made where they meet. Okay, they don't have to cross. So here we've got two lines that intersect, they cross each other. We could have, I don't know, one line, let's do a line like this time, and let's do another line that just meets it here. It's not going to cross it, it's just going to meet it. Okay, so here you can see we're going to create two angles, one here and one here. Okay, the last option, when you have just lines meeting, could be that they meet to create a vertex. So we could have a line here, and then let's say another line like this. Okay, so where these two lines meet, we'll create one angle there. Okay, so these are kind of the three main cases where you just have straight lines that are meeting. Okay, they could be in a context. This could be, I don't know, this could be a triangle on a straight line. So you could be looking at the sides of a shape meeting. Could be a physical context. Maybe there's two fences that go straight along the edge of a garden, and then they come straight along the other edge, and they meet at an angle. Okay, so you've got three options where you've just got straight lines that meet each other. The other way you can think about angles is maybe you start off pointing in one direction. So let's have, I don't know, maybe we're facing this direction, and then I'm going to turn through an angle to face a different direction. So let's say now I'm facing this direction. Okay, so the other way you can think about this angles is rather than it being two things meeting and creating an angle, something turning around at an angle. Okay, typically when you turn left or right, you're turning 90 degrees clockwise or anti-clockwise. Okay, so they're kind of the two contexts. You've got where straight lines meet, and you've got kind of a rotation happening. Okay, so there are two ways you could be looking at angles. Right, let's have a look at categorizing angles then. So there's three main ways, three main types of angles we talk about when we talk about angles. The first one is acute. So let's have a look at acute angles. Acute angle, as people remember, acute being cute and small, is an angle that is greater than 0. Okay, but it is less than 90 degrees. Okay, so it's greater than 0 degrees, less than 90 degrees. Let's call our angles x, shall we? Okay, so an example of an acute angle would be anything up until 90 degrees. So 90 degrees is like here, I would say. So anything less would be something like this. That would be an acute angle. It's not the only one. Obviously, there's loads. I could have done a really skinny one like this. That would be an acute angle. I could have done a really one that's close to 90 degrees, but just under. So let's do this one here. Let's say something like that. That would also be acute. Okay, so that's your first kind of angle, is acute. Next kind of angle is obtuse. Obtuse angles. Okay, so that is less than 180 degrees, so it's less than a straight line, but it is more than 90 degrees, so more than a right angle. So we have 90 degrees, which is more than, let's call our angle x again, and it is less than 180 degrees. Okay, so that means we've passed this 90 degrees that we said about before. So we've gone a little bit past it, or we could go quite a bit past it and nearly a straight line. So let's have a look. I'll do a couple of examples of this one. So from this line, 90 degrees would be, well, you could either go 90 degrees this way or 90 degrees this way. Let's go down, shall we? So 90 degrees down would be down like this. So let's just go a little bit past that. Let's say something like this. Okay, and that angle created there is an obtuse angle. Okay, let's do another one. Let's say we have a really close to being 180 degrees. Shall we have one like that? And like that. We've got this angle here, would also be obtuse. Okay, so this is the region which you have obtuse angles. This is the region where you have acute angles. Let's have a look at the last one, which is reflex angles. Okay, reflex angles makes up the rest of the circle. Okay, so if you're thinking of the rotation of being looking around a circle, then reflex angle would be from 180 right up to 360. Okay, so 180 degrees. It's going to be greater than that, but it's going to be less than 360. Okay, so a reflex kind of looks a bit like an acute angle, but instead of looking at this small angle in here, we're going to be looking at the big angle around the outside. And it's the same for obtuse. Instead of looking at this angle around here would be a reflex. So let's have a look at a few, shall we? Let's do a really, really skinny one, shall we? So this angle in here, inside them two lines, would be acute. But this angle around here would be reflex. Okay, let's do one that's got an obtuse angle as the smallest angle. So something like that. And then like that. So this angle here is more than 90 degrees. So this angle on this side would be obtuse. This angle on this side would be reflex. Okay, so your reflex makes up the rest of the turns. Now, having a look at these, there's a few things you might notice. I've not put any equal to signs here. They're always greater than or less than. Okay, there's a few reasons for that. Firstly is an angle of, why am I not including 0 degrees here? Well, an angle of 0 degrees, if you think of it in this context, if you are pointing in one direction and then you turn 0 degrees, what way are you facing? Well, you're facing the same way, okay? So you're not really turning at an angle. So 0 degrees is not really an angle you can draw. If you were to draw it, you'd start out by drawing a line. Okay, then you'd have to think, well, from this point, I need to move 1 degree. Let's say we're going to do it clockwise. 0 degrees clockwise. Well, I'm not going to turn anything, so you can't really draw it because it would just be a straight line. Okay, so that's the reason we don't include 0. Okay, 90 degrees is not included in either of these, look. 90 degrees is a special case. Okay, 90 degrees, I'll do my best to draw a 90 degree angle, is the special case between acute angles and obtuse angles. There should be this notation in here. If you put a square in there, that tells us it is a right angle. This is 90 degrees. It's kind of the special case. Okay, it's the one angle that has its own special name. Okay, there's a few different things you can call this. You could say it's a right angle. Okay, when we're talking about two lines meeting at 90 degrees, you would say they meet perpendicular to each other. So perpendicular. Okay, so we've got 90 degrees being right angle or perpendicular. Okay, the next angle that's not included is 180 degrees. Right, so 180 degrees is a very useful angle in maths, but let's try and draw it. So we're going to start from a line, then we're going to go 180 degrees. So from, this is the point we're turning around, so we're going to go 180 degrees. Let's turn, and it would end up like this, a straight line. So it's a similar thing to the 0 degree angle here. It's very useful, 180 degrees in maths, to solve things, because angles along a straight line we know have to sum up to 180 degrees. So if we were looking at something like this, we know that both these angles have to add together to 180 degrees. But if you're just drawing a line that is 180 degrees, it's just a straight line. Okay, and there's a reason why we don't really count these as angles, because, well, there's a 180 degree angle here, sorry. There would also be a 180 degree angle here. There'd be a 180 degree angle here. There'd be an infinite amount of 180 degree angles along this straight line. Okay, so it doesn't really make sense to call that an angle, even though we're going to use that in maths to solve problems. Okay, so 180 degrees isn't really an angle, it's just a straight line. Okay, and the last one, 360 degrees. I'll tell you what, we'll look at angles bigger than 360 degrees, and you'll see the argument holds for this one. Okay, so let's imagine we have an angle that's greater than 360 degrees. What are we going to call it? So let's say 370 degrees. Okay, so we're going to start off with a line. Okay, from this line, we're going to go round 360 degrees. So that's 360 degrees. We're doing 370, so we're going to have got an extra 10 degrees. Okay, which means our line is going to end up here. Okay, so as a rotation, this angle exists, and that's fine. Okay, but we could always write this as either a 10 degrees, or we could write it as its reflex angle from here to here as, what would that be? 350. Okay, so it does exist, but it can always be expressed as other angles. So you may as well use it as an acute angle, because it would be easier to work with, or a reflex angle, which could be easier to work with depending on what you're trying to work out. Okay, so this kind of holds up for this 360 as well. If you were to go round 360, I'm going to use my 1 degree example. So you're starting off facing this direction, and you do a 360 degree turn. You've gone all the way around here, but we could also write that as a 0 degree turn. We're back to where we're facing, so it's not really useful in terms of just an angle on its own. We will use the fact that if you go all the way around, it's 360 to solve problems, but you wouldn't say that that is an angle of 360 degrees.